Hey everybody, this is Larry. This is me trying to do something new, which is that I'm going to try to do one problem that I haven't solved before. So, because the daily problems have been repeats for me. So, yeah, let's see. Let's check that out. Let's just say to do. And yeah, let's just click on it. Is there an easy way to just like pick a random one? Pick one? Does that work? Have I solved this before? Let's see. Oh, okay. Maybe we should pick one that isn't premium. Is there a way to click on that? No? Okay, let's try again. Okay. And I haven't done this before, so let's go. So today's random problem is 963 minimum area rectangle 2. Let's see, the given array of x, y points where points of I is equal to x of I, y of I. Return the minimum area of any rectangle form from those points, given that the sides are not necessarily parallel. Okay. I think so. This part is. Let's see. Well, let's figure out what n is. Okay, n is 50, so it's. So the tricky part isn't going to be the complexity, right? Because now you can choose 4, which is 50 to the 4th or something like that. Or if you want to be a little bit, what's 50 to the 4? Maybe 50 to the 4 is a little bit too much. Yeah, that's 6 million, and in a lot of languages that'll be okay. Python may be a little bit too slow, but we'll see. But that said, if you're given 3 sides, you know where the 4th one should be. So you could optimize that way for sure. So we'll talk about that in a bit. But the second part is just figuring out. Oh, it's a rectangle, not a square. Huh. Okay. I mean that. I think square there are like cuter tricks that you can do, but a rectangle is fine as well. It has to use all 4 points. Then okay. I mean, I think it's just about, so we can try to do this in n cube, and that's what we're going to do, or n choose 3 maybe more specifically, which I guess that's maybe faster. Let's see, because I'm just googling 50 choose 4, because 50 choose 4 is not quite the same as 50 to the 4th, right? 50 choose 4 is apparently 230,300. So actually that'll be fast enough. So we do. I think that's the difference between n choose 4 versus n to the 4th, right? Because n choose 4 is technically roughly all of n to the 4th, but it is at the very least n over 4 over 24-ish, right? So yeah, I mean it's actually less than that even, but as a result, 50 choose 4 is way less, so we can brute force it. So let's try. So first we do this, the loops. And then the question is, well, what is a rectangle, right? A rectangle means that given a rectangle, also I have to double check that we don't duplicate, but I think this should be okay. But because we do it this way, we have to be careful that we have to try orientation. This is an annoying problem though, but mostly because I'm not very good at geometry. But yeah, I think here so what is a triangle, right? Oh, sorry, what is a rectangle? A rectangle is, 2 sides. Well, a rectangle is 2 sides, or 2 sides equal each other, and 2 sets of sides, if you will, and they oppose each other, so you don't have a diamond type thing, right? But I think the tricky thing with the way that we're doing here is that we're not trying all possible orientation, so we have to be a little bit careful. And I think the way that we'll have to I think given any, so one way to think about it is that for every 2 points, so I don't know if this is quite generalization, but so you have 2 points let's say I and j, and then you have k and l, those sides have to be equal, right? Oh, but so I guess obviously having 4 sides being, that is not enough because you have to do the angles. So basically, okay. So let's maybe list it out. Right? First, so first, sorry, my Alexa was pinging me, so I had to tell it to stop. But so first, a sub I plus a sub j should equal to a sub k plus a sub l, right? And also the other case as well, because you can just think about it as visually the points, and then the possibilities have to be even the. Oh, maybe that's the way to do it, because if, let me draw it out actually, because I think I've been doing hand motions a lot. Okay, so I think this is right now. Okay, let me put on the screen. And sometimes learning these problems is kind of doing these explorations. So I'm very excited about that. Maybe I'll use it in the future because I didn't, or maybe I probably knew it in the past, but I don't know. So there are a few ways to do it, right? And I think the first observation about opposing, let's say you have oops, that's a J, right? I, J, K, L, and it can be in any direction really, right? Then here, if we take any 2 points that are not, or if we take 2 lines that are not next to each other, they have to be the same, right? So that means this has to be the same with this, and this has to be the same with this. But of course, this isn't a rectangle by the virtue of the obvious thing, which is that it is not axis parallel, right? Or sorry. Well, it's also not axis parallel, but it's just a diamond, right? Because it has to be 90 degrees. So then the cube thing is that you can also actually check one additional thing, which is the 2 diagonals. So given these 2 diagonals, if you have a rectangle, then it should be the same as well. And in that case, now that means that for a number a sub I, or a point a sub I, it will have to be equal to, so that means that all the line pairs have to be the same, right? So I think that's good enough for me to get started on programming. Hopefully that made sense for you at all. Okay, so yeah. So this length has to be the same, and what I'm saying is that this length also has to be the same, because that's just the other side. But also now the diagonal has to be the same, assuming, it depends how because these points go every way, but now this is way easier in the sense that we don't have to worry about orientations and stuff like this, right? So yeah, let's see, how do I say this? Let's see, right? So xi, no, maybe just xi, yi is equal to points of I guess just this, because maybe I could just put it here as well. And then xj, yj is equal to points of j, xk, yk, points of k, and then xl, yl is equal to points of l. And then here, like we said, so then the length of all of these. So yeah, I usually actually would write a helper function for this, but I feel like Leetcode is very slow. Okay, so yeah, let's just do it anyway. We'll see what happens. If it's too slow, we'll optimize it out. So we have, just say length 2, and why I say length 2 is just so that I yeah, maybe just AB, and I don't need all this stuff then. Maybe that was just fun. But length 2 is because I want it to be length squared. And the reason why I say that is because now we can do something like a sub minus b sub 0. So we have this square, or just times itself. Maybe that's a little bit easier to write. And the idea here is just that so we don't have to worry about square root or something like that, and everything will fit in a integer, or and by integer I mean like, you know, like whole number, right? So yeah, and also all the signs will be positive and stuff like this. So there's a lot of benefits here. So then here we go if length 2 of points of I. So now from points of I to points of j is equal. Well, let's actually store this so we don't have to do you know, Lij is equal to this. Lik is equal to length 2 of sub k, something like this. L. Okay, that's a little bit awkward, but yeah. And then now Ljk is equal to length 2 of points sub j points sub k. Length jl is equal to, basically this is all 8 or 6 possibilities. Maybe I could have written this a little bit more clever, but nonetheless. And then LKL is equal to length 2 of points KL. And of course, the thing to optimize, minor things to optimize here is just putting this here so we don't do duplicate work. And I sub k we can put here, for example, and j sub k as well. And then the last one is just these things. And then here we go, okay, if L sub ij is equal to L sub KL. Hopefully this is right, otherwise we did a lot of stuff where it is wrong. So Ik is equal to JL, and what's the last one? IL is equal to JK, right? Then count increment by 1. Yeah, that means that do diagonal, right? All possibilities. And I think this maybe is a good start. Hopefully this is right. If not, then it's a little awkward. Oh, did I misread the problem at all? Oh, minimum area of any triangle. Okay. I mean, that's fine. Wow, I totally misread the problem as count, but that's fine because we're still trying to find a rectangle, and this is a rectangle, right? And now that we have these sides, we can now think, what is the area of the triangle, right? Or sorry, what's the area of the rectangle, and then we do a min of it or something like that. So we have the hard part done anyway. So best is equal to minimum, right? So maybe we can do 1e30 or something because we want the angle. How you do the so this part we would have to do the square root, but now we have to figure out the side that is the most accurate. So I guess coming out, if you just look at, and this is me just thinking off my head, but if you have Li, Lj, Lk, and you could draw it out, for every point, the longest one is going to be the one that is the diagonal. So then you can just figure out the other one, the 2 is not, right? So that means that we can do something like maybe this is too awkward. Lk times Ik times Lil over the max of Lij, Lik, Lil, right? So best is equal to min or best of this. If best is greater than 1e30, then we return 0, maybe 29 just for a rounding error. Yeah, and this is because that we want to get rid of the max because it's the other 2, right? And as I mess this up, dong dong dong. This has an area of 2. Well, why do I think it's area of 4? Oh, I am dumb because I actually was thinking about this, but then I totally forgot about it as I was doing it. but because this is squared, right? So then now we need to square root these numbers. But that's okay. We can do that. Yeah, okay. So then now we just have AB. Okay, fine. I'm trying to think whether I could do it in a clever way, but I mean, I think you could just you could probably also just square root these, but then the max part doesn't really make sense. So no, I think it still makes sense actually, because then now, because the square root is inside, then you take it out anyway, and the max of the square root will be the same as max. Okay. I mean, it's very awkward looking though, for sure. And this is also one of those things where, you know, you see someone's solution and you're like, what is this guy thinking? Like, how do you even get this formula? Well, if it's right first, we'll see. Maybe it's too slow. Is it going to be too slow? I hope not. Maybe if it's too slow, I have to use another language, because I think this is super good in... how close am I? This is going to be super good in like C++, because this is only... I think the square root maybe is an issue, to be honest. But... And you can maybe delay the square root until later, but I think this is... trying to think whether... because we don't do that many things, but I guess there are just a lot of cases. Because like we said, 50 choose 4 it's like 200,000 or something. Whoops, where did my finger go? I minimized it by accident. Okay, so 50 choose 4 is only 230,000, but maybe we do a lot of cases. But this is what I was worried about with having these functions. But this is just like tedious, right? So okay, but let's fine. I hate this. I'll try to do this first before I convert it to before I convert it to whatchamacallit, C++ or something. This is way, you know, I'm not learning anything by this though, so that's why this is sad. Maybe we could use this as a benchmark actually before I see if I can use this as a benchmark a little bit. That seems like a big... I mean, it has at most 50 numbers, right? How much of a benchmark can it be? How slow can it be? 385? Let's see if this actually speeds it up. And also worry about typos with stuff like this, obviously. Very easy to have typos. I should have also done the inner ones first, just because I think the inner ones technically executed the most, right? Then I could just see to see if this is much faster. Just for purposes, we got rid of half of these, but they're not proportionate, right? So this is actually slower, but I don't know. Maybe now I don't know, friends. At least it's still correct, so I haven't made a knock on wood typo yet. Though if this was a contest, I would be pretty sad about it, not gonna lie. KO. Alright, let's see if this is better. I guess the worst part is that this could potentially have that many square roots. This is actually slower. Is that true, or am I just like unlucky? Yeah, okay. Well, in that case, Yeah, let's change to C++. Maybe it's just, let me think whether, I mean, I guess we could do end cube and try to find the third point. Yeah, okay, fine. I think maybe, but 200,000 is not that much. I'm relatively, like, I feel like if I did Java or something, like, it would be faster. But yeah, I guess I knew that this could be a thing. Okay, fine. That's, so yeah, this is gonna be, I'm just annoyed that I thought entries 4 would be fast enough. But this is also a thing where, you know, like the number of test cases matter, right? If I have one test case, this is obviously fast enough. But as you can see, but given 100 test cases, maybe it's a little bit too slow, right? Hard to say. Okay, so let's think about it again. Let's try to do it for n cube. The idea behind the n cube algorithm is just the same idea, right? So given I, j, and k, let me actually take the one that I took, because if that didn't save enough, then I'd rather have this code because it's easier to see. Okay. Then now we can figure out the third point, right? So, but then now we can also do it in a harder way. So then we can make sure that we get the two corners, right? And the idea here is, let me think about this for a second, is the idea that I'm trying to think. Okay, so what do we want it to be? Given I, j, and k, let's well, first of all, yeah, now did I just take out the first one? Now we have to do all three, but then if I is equal to j, we continue, of course, and yeah, if I is equal to k or j is equal to k, we continue, right? I guess you could have also checked for this being 0, but that's more expensive. Okay, and then now the idea is that, okay, what's the easiest way given these points? Do I have the thing still on screen? Because that would be actually kind of sad. Let's see. Okay, so I am now putting this back on screen. So let's see, right? Let's say I have, why is this red? Let's say I have something like this. Actually, no, I don't need the diamond anymore. That was just a different case. Whoops. Let's say I have a rectangle, right? And pretend that's a rectangle. I can draw. And now we're given I, j, and k. So what can we assume about this, right? So here, what is the assumption? How do we get this L? I guess this is just like vector math, but I am very bad about it. Okay, so I guess it does. So I think we're trying to find a diagonal again. Oh, wow, I kind of used the wrong brush for that one. And if we figure out which line is the diagonal, so we basically, okay, so then to figure out the diagonal, we just have to make sure that, yeah, okay, I think I have an idea, which is that given we figure out the diagonal, as we said, that's the longest length, right? Okay, so then now we have ij and ik. Oh wait, no, we don't have L. Sorry. Oh man, I am not thinking about this. Right. So we're just given this and this. But I guess the worry is that you know, maybe this is K instead by accident, right? What if this is K instead? Then how do we rule that out? And do we have to rule it out? I guess not. I guess we could just look for it, right? Because what I wanted to do is basically the IJ translation. You could think about it as a line, but it's also a translation. And then we operate it on the K, right? So let's say we kind of copy and paste it here, and then we just try to see whether this L exists. And then after that, we can figure out whether this is a thing by the thing that we said, right? The two diagonals. Okay, yeah, let's give that a try. I think that's a possible thing. So yeah, okay. So we don't have to, we can just find the fourth point and then see if it's a rectangle. So we already have all the components for this, right? Okay, let's just keep these. Actually, let me go back to what I had before. This is the one I had before I deleted stuff, because then I can reuse some some of this per se. Probably, possibly. Okay. And then now what we want to do is figure out what L is, right? Oh, and we have to do the lookup. I forgot to do the lookup because I've been a little bit switching from before. But yeah, why not? So okay. So for point in points, tuple of point, right? That's fine. Lookup dot add. Or maybe scene is better. We just want to set. That's what I'm trying to say. Oops. Okay, so now we have a scene, and then now we can just say, okay, given ij line, add k to find L, right? So okay, so the dx is equal to point sub I, or point sub j, I guess, technically speaking, minus point sub I. I wish there's like a pairwise thing, but okay. And then now we can take the k and then do the translation, right? So L, let's just say PL for point sub L maybe, is equal to point sub K of 0 plus dx point sub K of 1 plus dy, right? And then now we can do the things that we did before. Except for now, instead of this, we have PL. And we also have to double check that PL isn't one of the, I don't think that is possible, but maybe we have to check whether it's equal to ij and k, but I mean, as long as it's not 0 delta, it should be okay. So, and there are unique points, right? Yeah, all the points are unique, so it should be okay. And then now we have to, I guess we just do this thing, really. So yeah, so I guess we had most of it. We just have to do an optimization on finding L. I didn't even have to change that much, really. Okay, this is the wrong answer, though. Wrong answer is that. Why is that? My answer is smaller than expected, which is not. Oh, well, also, I guess I also have an answer for this one. But, oh, I'm dumb. I forgot to check. So, of course, my answers are better. So here, I have to check if PL in not in scene, we continue. Oh, wow, what a silly mistake. I mean, that was the whole point of this optimization, but I just forgot about it because I was focused on the other parts. So that looks okay. This looks only slightly faster. Let me run it. Oh, yeah, let me run it once more. But yeah, okay, let's just give it a go. Maybe it's fast enough. If it's still too slow, then I'm just going to be sad and cry. Maybe we have to do some optimization on the other parts, but come on. Okay, wow, this is very slow. Maybe I could move this bit underneath, maybe, but let's see. Yeah, so that we, I don't know if that's the most expensive part, but I'm sure it helps. But that's still like so slow though, huh? Maybe it's the square root. Oh, I guess that is so expensive. Look at this. This is what I was talking about. And I think if I had the not function calls, it would be much faster. but I'm not going to spend time optimizing that part. Cool. Yeah, yikes. This is pretty tough for an initial one. So let me know what you think. I don't know how long I'm going to do this or how often I'm going to do this, but I'm going to try to do it a couple of times and then see the reception. So if you do like this and you want to see this more of this, let me know. Stay good, stay healthy, to good mental health. Leave it a comment below. Give me some love and support. I'll see you later and take care. Bye bye.